Well, I'm finally back for the 2 or 3 people that actually watch my videos. Been out of the loop for a while. A lot of personal stuff going on. Life gets in the way as normal. Running people back and forth to doctor appointments and feel more like a Uber driver than working on my cars. So this video is going to cover the dashboard. Basically the analog dash clusters. I do have an electronic dash cluster somewhere, but can't seem to find it at the moment. So I'm running analogs in my cars, so that's what I'm going to focus on. To do the dash, we've got 2 connectors, a gray and a red. The gray has the battery and the ground, actually the ignition and the ground input. I've got a car battery running through a 5 amp fuse on the positive. I've got a secondary 5 amp fuse off positive that I can use for my lights. And then I've got 2 ground that are also fused. I can't stress enough that if you're connecting your dash to power and ground, I would highly suggest running fused wires, because I can't tell you how many times in the last couple of days playing with this that I've shorted out something and blown the fuses. So I don't want to risk blowing the dash out, and fortunately I haven't had a problem with that. One thing I do want to recommend are these PosiTap fuse holders. Make it real easy to change wires. So if you're trying to complete a circuit, you can just cut the wires and splice in a fuse, pull the fuse, change whatever you want, but it just makes it real handy to play with. So one of the ways that I have occupied a lot of my spare time instead of working on the car is actually working on schematics. And I've gone in deep diving into the manuals, changing a lot of things because I found errors in there. This is a layout of the printed board on the back of our dashes, which basically just has copper on the outside, and you can actually put a probe to these and see where there's power and ground. And I've also labeled this on my schematic. So I've labeled the components as far as the connectors. I've numbered the connectors. I put in the inputs to each function, and this stuff's found in the manuals, but it's not in one place. And then on all these traces, I've labeled the positives and the negatives. So if I'm in there trying to trace something, this is the ribbon cable for the warning lights. Just makes things a lot easier to find. What I was wasting a lot of time on was when I was tracing a circuit, I'd have to keep going all the way back on these traces to find out where they actually went to. And now I've actually got the traces individually numbered. So like if I was going to that pin, I would know that it was a positive and it's pin number 9. So I come up to pin number 9, so I know that my input is coming in through the gray connector, and that's going to be the hot for the dashes. So that's my main ignition power in is on pin number 9. I've also labeled out the connectors as to which function each one has. The color. If you go to the manual, they're both labeled in alphabetical. They skipped the letter I, but they were both the same, and I was getting the connectors mixed up as to which one was which. I had to keep going back to the color, but if you're in a schematic, it doesn't really show the color, and so I decided I would renumber them to be 1 through 11 instead of A through K. So that made things a lot easier. I know which connector I'm dealing with a lot quicker when I look at my schematic. Something else that makes it a lot easier to work on these when you're playing with the wires is having connectors from junkyard cars. Whenever I would pull a dash out of a vehicle in the junkyard, I would cut the wires to these connectors so I get the connector and the dash. So when they're together, it's no extra charge. I've actually also got the connectors for the electronic dash, and in my car I've actually spliced together the wires so that if I can swap dashes back and forth going to analog or electronic just by swapping the connector into the back of the dash, and I'm good to go. I don't have to actually splice the wires again. So that's just one handy tip if you can still find old dashes. Still see a lot of LeBarons in the yards. Not a lot, I would say, but they aren't really rare yet. I don't find too many Daytonas and Lasers, but you can still get LeBarons. There are a lot of those out there. And they've got the same dash cluster. Depending if you got an electronic or an analog, you can steal the connectors out of it and the dash with it, dash cluster. Now the normal dash bulbs, the cluster bulbs, are these old style filament bulbs. And when you pull them, you'll find a wire on one set of wires on each side. This doesn't have a wire. This is just blank glass. This side has a wire on it. And these get folded over, crushed, and don't have good connection. So if you're having problems with your lights not working, you can pull those wires up and get a little bit better connection inside here. And also clean these terminals up with sandpaper, and inside here with a little file you can crush these pins together. That gives you a little bit more connection. But rather than waste your time with these bulbs, it's amazing how hard they are to get out once in a while. I would just replace them with LEDs. Now, these are from SuperBrightLEDs.com. This is a cool white, which replaces the stock bulbs. You can also get them in blue. So, the nice thing about these LEDs is that they are dimmable, and that they're also not directional. So when you swap them out, it doesn't matter which is plus and minus, they still work. So I thought that was pretty cool, because usually LEDs are directional. They only work in one way, and it's always a pain, the 50-50 chance of getting it right. So these are nice, but again, the really important feature is that they're dimmable. They don't just full bright or off. So keep that in mind if you're ordering bulbs. The blue ones, that's the blue, and I've also got green ones, and I haven't decided if I like the blue or the green better in the car. The Laser's pretty much set up for the green, but I think I might be switching to blue. I'm going to play around with both. For about $3 a piece, it's well worth it, and get rid of these bulbs that are not only are they a pain to work with, but they suck a lot of juice out because they're filament type bulbs. LEDs take less power. So, one of the things that always bothers me is not knowing exactly how a circuit works. And I came across this on the temperature sensor for the coolant, is not knowing how it worked and actually which sensor it's using. And I was totally wrong on what I previously thought. I've read manuals and they don't make a lot of sense. So this is actually your temperature sensor, and I always thought it was a switch, either it was on or it was off, but it turns out that it is actually a sender that changes resistance with temperature. and this is on the passenger side of the cylinder head. So when you look at the engine, this is the one that's doing the gauge on your dash. This is the one that's going to the SMEC, the engine control. So two different things. This one does not get used in the gauge at all, which is, I always thought it was. So if you're ever looking for which one is which, that's the one. So how I set this test up is I've got my ignition feed coming into the dash and through the blue-white wire. I've got my ground wire coming in through the black-orange wire. I've got ground coming to a pot, a rheostat, and then I've got my signal output coming to the violet-yellow wire on the connector. Don't know if you can see that or not, but that's where it is. Alright, hopefully you can see this. Zoom it in a little bit. So right now my gauge is as low as it can go. My voltage is at 12 volts. And as I increase the temperature, it's actually decreasing the voltage that's coming in. So you can see it doesn't quite get to 0 volts. If I went to 0 volts, it'd peg it. And if I went to 12 volts, it's pulling it all the way down. So what's that tell us? Well, our dash, the violet yellow wire, is putting 12 volts on this pin on the sensor. And when the sensor is open, the dash is seeing that 12 volts. So as the engine heats up, this starts to close internally, the resistance starts to decrease, and we lose that 12 volts because it's going to ground. So when we drop the 12 volt signal, our temperature starts to go up because we have fewer volts coming in. So it's allowing the voltage to pass to the block, and that's cutting down what we have available back at the dash, because the signal comes out of the dash actually. What I'm going to do is, we've got the gauge on the dash cluster. You can see the voltage is 11.3, and here I've got the temperature sender. So what I'm going to do is heat the sender up like it was in the cylinder head, and we've got a ground wire coming to it, and we've got the violet yellow wire coming in on the end. So we've got 11.5 volts coming in on the violet yellow wire from the dash. So as I heat the sender, you can see the voltage starting to drop. And you can see the temperature gauge going up. So the way to easily test is with using a 9-volt battery, a couple leads on it. You want to make one of those leads fused. Put your negative on the violet yellow, put the positive on the blue white, and your gauge will just about peg. It's just under hot. Now to test the oil pressure gauge, I do the same thing. I put my positive on the blue-white and my negative on the gray-yellow. And you can see the oil pressure starts to come up. So what's important in here is to know which sensor is which. So this is your oil pressure sensor that's talking to the gauge on the dash. So you've got one wire coming in and it's sending in 12 volts, and it works just like the temperature sensor did. This one down here with the terminal on it, that's your sender, and that's just a switch. So when you have low oil pressure, that shorts out and sends a signal to the gauge on the or the idiot light on the dash to tell you that your pressure's gone. So this works with the gauge, this works with the idiot light. So for the fuel gauge, we take the 9-volt battery, put it to the ignition circuit, the blue-white wire, on the positive terminal, and then the negative terminal goes to the solid blue wire on the gray connector, and you can see that starts to bring the gauge up. So with a 9-volt battery, you're running around a third tank. So what this shows is that if you had this in your car all wired up and you wanted to test it, you take a 9-volt battery, put the positive terminal into the back of the blue-white wire, and the negative terminal into whatever one you want to test. Now in our case, you want, for the coolant, we want violet yellow. For oil, it's gray yellow. And for fuel, it's solid blue. So by using the 9-volt battery to those terminals, you test the gauges. I can't do the speedometer or the Tach. I'm not 100% sure of how that all works. But this is a signal converter for the Tach, so it's taking the distributor pulsing signal and converting that into a voltage for the Tach gauge to use. The Tach gauge is mounted on the other side of these pins, and then your speedometer is on the other side of these pins, and that's doing the same thing. It's getting a pulsing signal coming from the transmission, and that's being converted into a voltage that powers that gauge. So it's pretty simple to test. Oh, also, forgot your voltmeter up in the top corner. That's already powered. If you unplug your gray connector, you'll see that that drops to 0. So that's internally run. So that's all there is to testing the gauges real quick. Like I say, you can do it in the car if you just pull the cluster out of the dash and use a 9-volt battery. You can do a quick test on it without having to do all the fancy test equipment. So this is what the stock bulbs look like that come with the dashes, and the bulbs are clear, but there's a greenish tint to the background, and I kind of like that tint, but then again I keep wanting to go to the blue. This is what the dash looks like with green LEDs on full brightness. This is what the blue LEDs look like. I kind of like the blue. I think the green is more pleasing when you're driving, but I like that blue look. Now here's one that I did not expect. These are the cool white LED bulbs, and they give a bluish tint, not like the factory lamps that actually show off as a greenish tint. This is kind of a light blue tint, so I'm kind of liking these actually rather than the dark blue. I think this is what I'll go to. So these are the cool whites, and you can see they're a lot brighter than the stock bulbs, and I think this is what I'm going to try. Something I'm working on for the Daytona is a different set of speedometer Tach gauges, and these are GPS based speedometer, and I'll plug it in. So one of the things it does is it eliminates the transmission sensor that I have a problem with, because my tire size never seems to match the speedometer, and it's off. Even changing the gears that are in that sensor at the transmission, I'm sometimes at 60 miles an hour, I could be 5 miles an hour off, and as you go up higher, I've gotten up to 100 miles an hour, over 100 miles an hour, and it's about 15-20 miles an hour off. So I have not been able to make it work. So I'm thinking that this is the best setup. It's also got a push button to zero it, but you can also do 0 to 60 mile per hour times. You can do quarter mile per hour times. It's basically a little a computer inside for track day stuff. And so I think I'm going to go with it. The only downside is I've got to mount it in here, and I took the stock gauge bezel and used that. This is a thread-on type nut that locks in, but now I've got to mount this in here. The good thing is I don't have to worry about the backlight. I guess I could show that when you put your bulbs in, you've got these clear plastic brackets that hold your speedometers and Tach in. That's what feeds all that light from the back bulbs through your cluster. So this is doing the work of transferring light around here. So just an option, not cheap, a few $100, but again, it'll do the conversion for me. You could probably also go with an external converter. You can buy them for around $100, that you can tweak whatever pulse you're getting from your transmission and make it do what you want. But that's what I'm going with. And I also went with the Tach just because I wanted to have kind of a matching set. I didn't want to have them looking different. But they're from SpeedHut, in case you're interested. This dash came out of an 85 laser. I assume Daytonas are the same. So I think everything before 86 was this style dash. And if you look at the back, it's different. Instead of the round connectors on both sides, this one has a straight set of pins, and also this one. So there is a difference in the dashes, the way they're laid out. It's something to keep in mind, that if you're doing the testing, the older style dashes do not work. Only the 86 through 89s, I think, are compatible with what I was showing you. This one's different, and then 90 came along and they changed to the rounded one. Also, I wanted to show that the ribbon cable that goes to the idiot lights ties in up here to these traces. So that's it for this week. I'm finally getting back to working on the car regularly, getting off the schematics, and hopefully I'll have the head on this weekend. And who knows, in a week or two I may have the car actually running. I'm not promising anything, but I'm getting tired of not making any perceive progress, even though the schematics were really important. I found a lot of errors in there that if I had to troubleshoot things without the proper schematics, it would have been a nightmare. So that's pretty much it. I planned to do a 15-minute video, and it's ended up being a half hour. I don't know why they always run longer than I planned, but hopefully I'll be able to start posting more progress.